Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 flight. We're going to be overflying Zurich, Switzerland, Germany, then come back to the Zurich International Airport 114 for an Lszh localizer landing, turn around in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and March Flight Simulator X. I'm going to start showing the cockpit instruments, displays, and functions of the Boeing 787-900 aircraft. I'm gonna start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude, above the ground level, the barometric altitude, above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute, all the stiffness of the trigonometric contours and degrees you can climb descent. We have also the altitude indicator with the pitch ladder degrees and the bank angle in degrees. We have the artificial horizon. We have also the Lszh localizer, the instrument landing system of the runways we use for takeoff and for landing. And we have the threshold antennas, the transmit the radio frequency that is received from the onboard antennas of the aircraft, so we can align with the horizontal localizer and the vertical glide slope for approach and landing. We have to tune a unique radio frequency each time we use a separate airport or runway, and also set a magnetic north pole heading that is equivalent to the runway heading. So we can align with the magnetic north pole heading and the Lszh localizer, the instrument landing system. Also we have the vertical glide slope, the angle of approach you can see later. Over here I will show you all the instruments. You can see here the primary flight display with the HSI, also the navigation display. So the primary flight display, what it displays, the navigation display, the horizontal and the vertical profile of the aircraft as it flies, the engines indications over here, the thrust levers. So we're gonna use all the instruments that we need here. We have the engine indications, we have the primary flight display, also the NCSI, the horizontal situation indicator with the magnetic heading and track, and the integrated display of the flight plan. We're gonna create a flight plan using the flight management computer. We're gonna input all the data of the aircraft using the flight management computer one by one, all the waypoints. So you will see them displayed in the HSI and also in the navigation display, and also we're gonna use the autopilot flight director system panel when we connect the autopilot with the flight director and the auto throttle. We can follow the LNAV, the lateral navigation and vertical navigation of the aircraft of the Boeing 787-900 aircraft. So we can see also we have the HSI, we have the navigation display, the magnetic heading and track, the magnetic north pole, the geographic north pole, the magnetic variation. Depending on where we are in the world, we have also the vertical display. You can see the terrain around you and also below you, depending on the distance of the terrain from the aircraft, vertically or horizontally. And also we can see different color indication like red, green, yellow, and amber indications. So we have also the terrain map has the lakes, the rivers, the sea displayed with blue. You can see in the terrain map also we have the airports, our own airport. We're gonna use for takeoff and for landing the Lszh, the Zurich International Airport in Switzerland. So we can use the runways and the taxiways displayed in the GPS for navigation. Also we have the waypoints, we have the navigation aids, the nav aids, which are the road stations, the ADFs, the NTPs, and also the waypoints, which are horizontal and vertical navigation fixes and all the airspeed constraints. We can select one by one all the waypoints using the flight management computer. All these things we have to do pre-flight. So I will show you all the systems of the Boeing 787 pre-flight, and we're gonna set up the flight. You will see the flight in the end part of the video, so stay with me until the end part. So we have the waypoints. We're gonna connect them in the flight management computer when we select the route or the flight plan or flight path of the jet aircraft. So thank you very much for watching me. I like flying jet airplanes, as you know. So you can see the outside view of the jet aircraft over here. You can see the jet engines. So you can see also. So we have here also, you can see in the navigation display, we can see also other aircraft that fly around our own aircraft. when we fly using the transponder. There is an ADC transmitter receiver. It transmits our radio frequency to other aircraft in the air traffic control and receives from other aircraft. You can calculate with his computer the other aircraft distance from our aircraft in nautical miles, like 45 nautical miles, so 72 kilometers away from our aircraft in a 360 degrees radial. Also the altitude difference between our aircraft and the other aircraft, the heading of the other aircraft, also whether the other aircraft climbs or descends. It will show us the other aircraft with a diamond shape, having the altitude difference with a plus or minus sign next to it. Also we will show us a narrow up or a narrow down if the other aircraft is climbing or descending. With respect to our aircraft, also will show us you can calculate the velocity closing in between our aircraft and the other aircraft. Will give us a warning from the TCAS system, the track collision advisory system. When we have an incoming collision in the air, we'll have to make an avoidance maneuver. You will see how we can use this system. Also we have when we are in the ground, you can display other aircraft in the ground, in the taxiways or in the runways for takeoff and for landing, so we can avoid a collision using the TCAS system, the track collision advisory system. We have also other systems to see. You will see all the systems of the aircraft before we go into flight of the Boeing 787-900 jet airplane. So you're gonna see also here, you can see the full setup, the mouse pad that I have here to control everything, the keyboard, the screen. So I use the keyboard and the mouse pad to control the autopilot and also the flight management computer inputs over here. Also I need to click the horizontal trim stabilizer, the flaps, the speed brakes, the overhead panel system. So you can see here I will show you now the flight controls and the thrust levers. So you can see here how the flight controls the side stick, so we can climb and we can descend. We can make turns to the right, turns to the left, or using the control wheel of the Boeing 77 is the side stick, left and right in the Airbus. Also climb, descend is the elevator both in Airbus and Boeing. In the Boeing you use the control column. As you see, the same function, no difference at all for flight controls system. Also the rudder pedals both in the Airbus and the Boeing aircraft have the rudder pedals to control the vertical rudder for left and right turns in the air, and also for nose wheel steering. In the ground we can control the nose wheel. As you can see here, we have the tiller, the left and the right tiller side, and also the toe brakes. So you'll see one by one the systems. Also the outside view over here of the airplane, so you'll see how the flight controls function. I will talk to you also about if we have some time. So you will see the displays here, the primary flight display, the navigation display, the ACAS and indication crawler system display. Also we will see from the flight controls, you can see here we have the horizontal trim stabilizer. This trim switch is very important when flying manually. We can trim the elevator up or trim the elevator down, and also this affects the pitch of the aircraft, the pitch attitude. We pitch the aircraft up or pitch the aircraft down without using the yoke as much as we have to, using only the trim switch. Also you can see here the elevator up, left click down, and right click up. So you can see this way you trim the elevator up, this way you trim the elevator down, this way you pitch the aircraft nose up as you fly, and this way you pitch the nose of the aircraft down as you fly. And also we have the trim, we have the control wheel here. As you can see, we can control the aircraft for flying like this, very easy using control wheel. Also the control column. So we have full flight controls like this. The elevator, as you can see, trim switch here, very easy. Also we'll show you the rest of the switches and the functions. You can see elevator trim, left click down, right click up. As you can read, we have the head up declutter also switch over here, the autopilot disengage over here. the flap speeds over here. You can see the displays, primary flight display. You can see the airspeed indicated. Right now the airspeed selected from the autopilot flight director system panel, the radio altitude above the ground level, the flight director crossbars like this. As you can see the flight director crossbars, you can see also the vertical rate of climb descent of the aircraft in tens, hundreds and thousands feet per minute. This needle moves up when we climb and moves down when we descend. You can see 500, 1000, 1500, 2000, 3000, 6000 feet per minute. This is moving up when you climb, when moving down when you descend. You can see also the altitude increase or decrease. We have to pay attention also the airspeed all the time. The pitch ladder here, you can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down. The wings level here of the aircraft when flying, also the bang roll. You can see like 5, 10, 20, 30, 45, 60 degrees for bang roll either left and right. Also the side slip indicator, the takeoff go around, the HSI, very important instruments, flight instruments. Also the barometric pressure above the sea level is 29.92 inches of mercury right now, or 1013 hectopascals, the radio minimum, and the landing altitude. No V-speeds yet selected with yellow and amber and black. And you can see here the barrel set from the FS panel. We can select, you can set inches of mercury. Right now is 29.92 standard barometric, or 1013 hectopascals. We can either increase or decrease and select either hectopascals, as you can see like this. Also set the radio minimum, so this is for the display of the map. Accept, cancel, reject, some warnings or occasions here. Systems, CDU info, checklist, communication, engine. Over here this displays autopilot, engage and disengage switch that you will see later, and auto throttle left and right. Over here you will see also the airspeed. We cannot change the airspeed. Flight director over here, as you can see, FD on and off. So you will see all the instruments, the autopilot also. So we have an aircraft that's coming in for landing, as you can see, very beautiful. That's spotted, Boeing 737-800. So we have also so you will see the autopilot, the airspeed selected. We're going to select lower or higher airspeed, the heading selected, magnetic north pole heading, vertical rate of climb descent, or angle of climb or descent, flight path. We have also the LNAV and the VNAV, you will see later, LNAV and VNAV connect, and the altitude over here. Also localizer and approach for autoland. So you will see also from the flight controls over here, climb descent. So we have the horizontal trim stabilizer, the HSI here. We have the heading, you can see magnetic north pole heading, 331 degrees, the range 80 nautical miles, map or plan, you will see also later. So here is displayed the Düsseldorf airport in Germany, DTL, is 65 nautical miles, as you can see. We have 40 nautical miles, 60, over here 60 nautical miles. From Zurich International Airport, the Lszh in Switzerland, one straight line in front of us. You can see 80 nautical miles the range. Also the terrain elevation of the map right now is 4,700 the maximum, 1,600 the minimum. You can see also when we fly above the ground, you will see the ground displayed with this needle is our aircraft symbol. So you can see the ground below us, some mountains when we have to fly in terrain or low visibility, like 10 nautical miles or less. We have some mountains above us. So you can see in front of us right now is the Düsseldorf airport, 60 nautical miles, and we have some mountains here in the left, like 10 nautical miles or 18 kilometers. You can see the mountains here, this mountain range over here. So it's gonna be more readily visible when we fly. Also the altitude, we have to fly above, as you can see over here. all the way up right now, set to 10,000 from the autopilot. So we're gonna change this altitude. You can change the display map view over here. So we have, I told you, horizontal trim stabilizer here, elevator up and elevator down, as you can see. Left click down, right click up. So we have also we have the alternate pitch trim switch over here, so we can use this switch to trim the elevator up like this way, or trim the elevator down as we fly, and pitch the nose up or pitch the nose down as it says. So this is to help the aircraft balance using the horizontal stabilizer. Also the parking brakes next to it, we have the stabilizer cut-off switch over here. We need to cut off if you have a failure of the hydraulic system that will affect the auto trim, either the left or the right stabilizer trim. So you need to cut off. This is for the Boeing aircraft. You have it here in the pedestal where the engines and the flaps and the speed brakes are, as you can see. So we have failure of this is a fly-by-wire aircraft. We have the flight control computers over here. So we have failure of the hydraulic system that will affect either the left or the right engine, either the left or the right horizontal stabilizer movement, or the auto trim motors movement. We're gonna have failure. Also we have to disconnect the autopilot here and fly manually. So we need to come down here. This is for all Boeing 737, Boeing 747, Boeing 757, Boeing 767, as you can see, Boeing 777 and Boeing 787. You open from normal to cut off this switch, and you use only the alternate, the manual trim switch, and fly manually the aircraft. So you trim all the time here using this trim switch. As you can see, pitch up and pitch down, very easy to control. I fly manually most of the time, so I don't use the autopilot. The Boeing aircraft is very easy to fly. Also here are the switch. So we have the control column of the Boeing, climb and descend, or the side stick in the Airbus. We have also the display here. You can see the engines indication, left and right engine indications. I will talk to you now. This warnings from the systems, landing gear down or up, extend and retract. So choose the landing gear, you pull up when you take off and pull down when coming for landing. Alternated gear and lock override. Over here we have some failure. The retract speed for the gear and extend and retract. Then we have the auto brakes also. Set rejected takeoff like this. You see RTO right now. Set RTO or off like this, or for landing set auto brakes 1. So we have also the flaps position. We have the stabilizer trim that I talked to you about, the horizontal stabilizer you can see, and now the rudder trim also. Here you can see the rudder trim position is 0 degrees right now, as you can see. So this is the stabilizer trim position. Inside the green band here is set for takeoff limits, within the takeoff limits of the aircraft that are calculated from its computer here before we go into flight. That take the takeoff gross weight and the fuel on board calculations. So we have stabilizer trim set here, rudder trim also, cabin altitude. When we fly we have the cabin pressurization system display here. Also in the manual, the outflow valves that open and close to pressurize or depressurize the aircraft cabin like this, as you can see. So when we fly to like 45,000 feet, 43, 44, 45, we have a cabin altitude pressurized inside the cabin of like 6, 7 or 8,000 feet. Right now we are at 1,400 above the sea level, and the differential pressure will go up to 7.8 or 8 psi. Also the landing altitude We have also the gross weight for takeoff here, 358,000 pounds, total fuel on board, saturated, air temperature, fuel temperature, the engine's indication. You can see the N1, which is the low speed side, also have low pressure compression tube, one of the turbofan tube, which is engine, the takeoff limit 99.8.2, total air temperature, green, red, yellow limits, the exhaust gas temperature in Celsius, the N2, which is the high speed Southern soft high pressure compression turbine of the turbofan tube, which is engine fuel flow points per 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine, as you can see, both left and right. So we have the flaps also set over here. You can see the flaps display how many degrees. Right now it's 30 degrees, is fully extended. So you can extend and retract the flaps, also the speed brakes. So flaps like this retract or extend. You can see how many degrees we can use the flaps lever. 18 degrees, 15, 18 for takeoff. So we set for landing. You can see also the engines spool up and spool down like this. So when we increase the engine's thrust all the way up, we will see the setting here. I will not configure for takeoff. It will give us some warning. These red warnings in the display. We need to do something before going to take off. Select some items here inside the aircraft. So we have a few more minutes to complete all the systems and the explanations. So we have the left and the right engine. We have the auto throttle, very important. Disengage here switch, the takeoff ground switch, the thrust reverser. Also the fuel control, left and right fuel flow, left and right engine, the fire extinguisher, left and right transporter, high frequency, very high frequency communication, radar trim over here, satellite, high frequency, we can tune standby and active frequency, ground proximity with the radar, select some systems. So you will see a few more things to do before going into flight. So I talked to you about the flight control computers of the aircraft. There is fly-by-wire aircraft, the Boeing 787. You can trim its horizontal tail, the left and the right stabilizer or the elevator, like the Airbus aircraft. When it's flying, it has the auto trim function. You can trim automatically from the computer, so we don't need to make inputs. So what we need to do, we make manual inputs. All Boeing and Airbus aircraft are pretty much the same handling. So we have only the flight control computers of the Airbus aircraft. When we climb or we descend the aircraft, they limit the acceleration of the climb or descent in terms of g. Where 1g is the Earth gravity acceleration. So we can climb an Airbus aircraft with a side stick up 30 degrees or 1.5 g, or a side stick down like minus 15 degrees or minus half g, as you can see. So climb 30 degrees, so 1.5 g, or descend 15 degrees or minus half g. Also in the Airbus, the Boeing has similar features. In the Airbus we can make left and right turns 2.8 g or 67 degrees, a full side stick deflection, and 33 degrees when we leave the side stick off. And also when we fly level, it accelerates, it maintains the aircraft acceleration in terms to the Earth gravity vector of 1g constant, so it trims automatically all the time when flying level, straight level, and adjusts the engine's thrust. So we can make turns with the Airbus left turns 67 degrees or 2.8 g, or right turns 67 degrees or 2.8 g, or when we leave the side stick at full deflection, it comes back to 33 degrees. Also we have the Alpha 4 protection system of 1G stall protection. When we fly the Airbus aircraft, it will give us takeoff ground thrust lock and limit the angle of attack of the aircraft, the side stick input, until we exit the stall condition. We have also maximum speed, the minimum speed protections, other protections. So the flight control computers take the input, the command from the side stick of the Airbus or the yoke of the Boeing, and they adjust the flight controls in flight in terms of acceleration of the gravity and rate turns or climb. So it's very easy to understand. So it's not full flight controls deflection at flight conditions at normal flight controls. So we have the normal, we have the alternate. You can see on our Boeing 737 again. It's coming for landing. So we have the flight control computers. We have the normal over here, the alternate and the direct mode of the flight control computers. Normal, alternate, and direct flight control computers modes. Also, but mechanical backup. So the Boeing has similar features. The flight control computers can be decorated, like the thing I showed you, the trim cutoff switch, the left and the right. So we have a trim wheel in the Airbus aircraft, Airbus 320, 330, 340. We have the switch here in the Boeing 787 or 777, also here, more similar to the Embraer or CRJ aircraft. So I'll talk to you now about how to use the outside view. We need to know some things about flying the aircraft, the air transfer pilot theory, the commercial pilot theory. We need to know flight dynamics, aerodynamics, the Newton's physics, and the burning theory of fluids. I will show you the outside view and how to use also the flight controls that I show you here very quickly. So we have the outside view of the aircraft. You can see we have the wings of the aircraft hold the weight of the aircraft when it's flying. The weight is divided over the surface area of the forward wings, where the weight acts down over the maximum lift from here, with the maximum lift in the wings. Also, we have the weight from the engines here. We have the thrust that pulls the aircraft forward from the engines, the jet blast, because this is jet engines. So we have the aerodynamic cord over here, the center of gravity over here. The left and the right wing fuel tank, the center tank. You can see we have higher pressure below the wings when flying. The pressurize the aircraft, as you can see. That pressurize the aircraft weight and wings up into the air, as you can see. Over here, the pressurized aircraft weight and wings up into the air. Also the top surface, you can see there is a higher curvature, so the airflow is moving faster, which sucks the aircraft weight and wings up into the air. So we have the thrust vectors from the engines. You can see we have the high pressure compressor and turbine over here, this section, and the high speed thrusters have low pressure compressor and turbine in the front. Also the fuel flow is coming down from this section into the engines, some fuel lines. We have the bypasser over here from the front fan. So we have two flows, one bypass and one high speed and high pressure core exhaust gas over here. So you can see we have two engines for stability. We have also the fuel coming down from the fuel booster pumps over here, from the fuel tank, left and right fuel tank. Also the wing and engine RDIs over here in the top surface. So we have the aerodynamic cord, where the maximum aerodynamic lift occurs in the forward wings, where the center of pressure is moving back and forth. Also with the stall, the airflow becomes detached. You need to pay attention to that. And the wings are stalled in flight. You need to monitor here in the primary flight display the airspeed indicator. You will see red and yellow indication. When flying is the stall speed, you need to avoid that. Pull down the yoke or the side stick and increase the thrust to exit the stall condition. So you will see also that. So we have the aerodynamic cord with maximum aerodynamic lift occurs. Is the position where the center of gravity is also position. We have the yawing axis. We can yaw the jetliner aircraft with using the rudder pedals, as you can see. So we use left and right rudder like this input, and also using in the ground only the nose wheel to make left and right turns together with the rudder. They're interconnected, so you can see here when moving the rudder pedals, either left and right turns like this. We also move the nose wheel, the tiller. So from you use in the air only the rudder. Also in the ground you have the nose wheel with the rudder, and you have the tow brakes to stop the aircraft. So from 0 knots airspeed up to 45 knots or 72 kilometers an hour, the forward nozzle will be deflected from the computer automatically up to 76 degrees, left and right. Also the rudder, also above 45 knots or above 72 kilometers an hour, the rudder becomes aerodynamically effective, and the computer will limit the forward nozzle to only 7.6 degrees left and right deflection. So above 80 knots an hour, 80 nautical miles an hour, or 144 kilometers an hour, the airflow becomes aerodynamically effective in the rudder, and the forward nozzle will be locked to 0 deflection or small deflection like half or 1 degree. This is how to use the yaw axis over here, the rudder pedals. So you take off only with the rudder like 250 kilometers, also you land, and then after you slow down, the nozzle becomes activated. So we have a couple more things to see here. You can see we can have the pizza axis, we can climb and descend like this using the elevator. So climb and descend the elevator. Also make turns right and left like this using ailerons and spoilers. Also the elevator is the yoke back and forth in the Boeing, as you can see. So climb, descend like this. Also we have longitudinal axis is the roll axis in the Airbus. Use left and right side stick input like this. Make left and right turns. In the Boeing is the control wheel. So no difference. Aileron, spoilers, also flappers in the Boeing. You can see speed brakes now fully extended. Also flaps fully extended. So you make left and right turns. You use aerodynamic lift between the left and right wing to make left and right turns. Use the control wheel in the Boeing or the side stick in the Airbus. So I'll show you one more view now of the flight controls of the Boeing 787, and then we go for the flight management computer, set up the flight management computer and go into flight very quickly. So you'll see now again one more time the side stick, the flight controls over here. Also the screen, I hope you like the screen views, so you can see we can climb and we can descend like this. Hope you like my control, my side stick over here. So we climb and we descend, we make turns to the right, turns to the left. Also use the rudder pedals. So climb and descend, make turns to the right, make turns to the left, very easy. And use the rudder pedals. So we climb, we descend, make turns to the left and to the right. Like this, very easy. As you can see, the screens also, the thrust levers over here. So you can actuate the thrust levers. So make right and left turns. Like this, the rudder pedals. And also climb and descend like this. So we climb and we descend like this, and make the rudder left and right rudder inputs. So climb, descend, left and right turns. So very easy to remember. Also all the thrust levers like this. So now I'm gonna show you the flight management computer. I will input all the data we need for the flight management computer, and then set up, make the engine start demonstration, set up the autopilot and the rest of the system. So we go now, you see the mouse pad, you see the keyboard here. We need for setting up the flight management computer data over here. So we're gonna make very quickly. You can see the index over here. identity, position, performance, takeoff, flight plans. We need to use flight plans, also the mouse pad here board. So we have here control quadrant. Very quickly you can see the view here. So we go here, identity, Boeing 787-900 GNX engines, install the RX cycle, the position, Lszh airport, Zurich International Airport in Switzerland, the longitude and latitude, align the coordinates over here, the index, performance, takeoff, zero fuel well, test fuel on board, gross weight for takeoff, cruising altitude, cost index, fuel freezing temperature, reserves. We're gonna set first the route Lszh Zurich International Airport in Switzerland, back to Zurich International Airport. Copy paste like this. Clear the discontinuity. Runway 14, very easy. Departures and arrivals, set departures over here. So we depart from runway 10, 14, 16, 28 or 32. So we select runway 14 and the seats is other into the departure waypoint services to Alpha. So we go now to the arrivals page, departures arrivals again. So we can use runway 16, 28, 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we set ILS 14, Trans Amity and Trans Negria 1 Alpha. So we set the legs, the departure first waypoint after takeoff, climb to the Zoe 6 nautical miles, then make a turn to the Negria, descend, approach and landing. Also align with the runway. We initialize here reserve fuel, zero fuel, fuel on board and gross weight for takeoff, cruising altitude 25,300 feet, cost index 100% over here. So we said 100%. We press the execute button, it will activate the route. So this is the route, the autopilot. We fly in flight if we connected. We can also fly it manually using the display, one waypoint by now. So we have initialized flaps for takeoff, 15 degrees, set and center of gravity 23%, 4.35 degrees to horizontal stabilizer, V1 V rotate and V2 takeoff, gross weight, runway position, route, departure, arrival, alternate, VNAV, progress, emergency communication, holdover, waypoint in flight, fix, set a fix, navigation, radio, tune, ILS and VOR ADF. So we go back in the legs and back over here, back in the virtual cockpit. So we can set here the navigation display. We can do this switching if we need. So you will see now we have a few more minutes left to go for takeoff. So we set up here the APU. We need to start the auxiliary power unit. In the start position, we have the left and right IGT, the great generator, 130, 200 volts, 400 head frequency, left and right engine, the battery, primary flight control computers in the auto position, heading, air data computer, flight control surfaces over here, battery down power, FD door, passenger oxygen over here, as it says, you can see, window seat over here, rammer turbine backup hydraulics, also left and right engine driving, hydraulic pumps, left and right engine driving, electric C1 and C2. In the off position we display the fold back to the on and to the auto position. We have the wing and engine, the eyes over here on auto position. Also the outflow valves for cabin pressurization in the auto position. In the manual we use the outflow valves to pressurize or depressurize the cabin by opening and closing the outflow valves. And in the auto we need to do nothing. We have the pressurizer from the engine for air conditioning, oxygen regulation, cabin pressurization, hydraulic fluid tanks pressurization, wing and engine RDIs. And also we have here the recorders. We have the cargo and APU fire. We have the electronic engine control. For the engines with the auto start, we can start the engines like this. Fuel jettison, we can dump some fuel, select the nozzles and how much fuel to remain. Left and right wing, fuel tank, the crossfeed valve, we turn it on, can feed either engine with other pump or either tank and balance the fuel between the left and right wing. So this is how to use the valves, like this. Fuel valves. So this is all the systems for the overhead panel we need right now. We go for the engine start in a couple of minutes. Show you first the flight plan here, the navigation display. Now you can see the flight plan. You can see also flight plan displayed with purple line. As I told you, the runways over here you can see purple lines, TRA, CI14 runway, terrain, also the vertical when you fly. Also here in the SSI you can see also the runway and the taxiway. We look closer, more terrain. You can see the runway, the taxiway we are parked in front, the other runway we're gonna use for takeoff and for landing. So this is the runway in front of us, and the landing, the runway actually, the taxiway, and the runway we're gonna use for takeoff and for landing. The train also as displayed in the navigation display. So we need also to look over this plan over here, map setting, as you can see, cursor. So we look further, we have more flight plan with purple, blue. You can see the takeoff ground mode, also more airports further away. So we look further when we fly. We have also the systems over here, display very quickly. Hydraulics system over here, APU is running, the oxygen, liquid cooling, oxygen quantity, electrics, left and right IDZ, 120 to 100 volts, 100 frequency, the battery charge, and its charge is connected, the Lszh, the drive and the APU is running. The hydraulics, where the hydraulic fluid goes, which systems use it, left and right engine driving, electric C1, C2, isolation valves, shut-off valves, also pressure 5100 psi, left, right and center. Fuel on board the aircraft would have a left and right wing, center tank, 111 and 11,000 total 34,200. The minimum fuel temperature below which the fuel will freeze in flight over here is minus 37 degrees, and the fuel temperature right now -6. So the FAREX that control the engine function also control the transfer of fuel in flight to heat up the fuel from the wings, tanks, left and right wing and center tank, to the engine components, then transfer the fuel back to the tanks to avoid the fuel freezing. Also the lubricant and the oil. Crossfeed valve with an feed either engine with other pump or either tank. Low and high pressure fuel valves feed both engines. The APU is fed from the left wing using the DC motor. So we have the air pressurizer from the engines, oxygen and pressurization. The doors are closed, the cabin can be pressurized here, temperature of the brakes and pressure of the tires. Flight controls over here when we fly, the flight control deflection, the tail and the rudder also, and the stabilizer trim. So this is one of the last things you need to do before going into flight, the flight controls function. So we have flight control, safety display, maintenance systems, circuit breakers over here, checklist, what we need to do before start, after start, after takeoff, descent, approach and landing over here. Communication, so we go back in the navigation display. We need to start the engine. We have the APU on running, so we turn on hydraulics. Here we go for the engine start. Very quickly, fuel control, left and right in the off position, as you can see. So you'll see the engines are displaying this hold messages are going off, fuel pumps off. So we look outside. We have the Boeing 787, as you can see. Its engines now are off. So we need to restart the engines, turn on both auto start over here, as you can see, left and right auto start over here, and all switches with number light for the auto start is turning on, and we have only pressurizer into the N2 stage right now. You can see 20%. We have no fuel flow yet in the Boeing 787. The airplane, as you can see, the hydraulics are turning on in a while. So we let the fuel flow like this, fuel control left and right, lensing on, and we have the auto start right like that. Auto start on. N2 is increasing, and 1 exhaust gas temperature, so now we have both fuel flow, as you can see. So above 50%, you will see the messages going off, the yellow messages. We have 55. So we have running engines. We can go for takeoff like this. The aircraft is ready. We need only flaps set for takeoff, speed brakes arm set over here. The autopilot, as I saw you here, you can see auto throttle left and right, on and off, the airspeed, set the airspeed. So we set the LNAV and the VNAV, later on navigation, turn off autopilot disengage, like this, bang angle and heading. We select the heading of the runway, 136 degrees. Also vertical speed set 0, level off. Descent, you will see a minus sign like this. Climb the other way, you see a plus sign. So we're gonna climb like 3,500 read. Also the altitude set thousands like this, and hundreds. So we have parking brakes off. We take the clearance from the air traffic control, advance the thrust levers. So we align here with the runway, we're ready for takeoff. We take the clearance from the air traffic control and taxi into the runway position, as you can see, using the tiller. So the tiller and the rudder pedals will align us in the center line, as you can see. Parking brakes on. So this is Thomas Hatsios, German American pilot flying the Boeing 787-900 tonight flight. Thank you very much. Stay with me. We just started the flight. For tonight, I'm gonna use full takeoff power and fly the aircraft manually. Also use a little bit of autopilot if needed for display. So we start right now. You can see here we have the thrust levers. We advance, takeoff, ground, and parking brakes off. We can use also here the thrust levers, the side stick that I have. So we use full takeoff, and we press the side stick down or the yoke until 80 knots, also align with the rudder pedals, some rudder input, because we have some side wings. So we have 100 knots, 120, 30, V1, as you can see we rotate. So we rotate pitch 9 degrees only for takeoff, 9 degrees or less, to avoid the tail strike, as you can see. So we take off with the Boeing 787. So landing gear up over here, as you can see. So we take off. You can see the navigation data we have right now. You can see the airspeed 195 knots. We are 2,000 feet above the ground, but 3,800 above the sea. We climb with 6,000 feet per minute. The pitch altitude 20 degrees. Also the stall speed here, yellow and red. The wind direction, the terrain, red, green, yellow, around us and below us. So we need to pitch down the aircraft a little bit as we climb, as you can see. So we have the terrain below us now to look at. So you see this green line is the terrain. Also the airspeed, the stall speed, 120 knots indicated. So you can see the terrain below us is gonna be 4,000 feet. The lines of the flight plan we need to follow over here as we climb, and also better view of the terrain below us. You can see this green wave over here is the terrain below the aircraft. The aircraft symbol is here, it's 8,000 feet, this triangle, and the terrain is 5,600, 700. It keeps climbing. This green wave below us, up to 20 nautical miles away. As you can see also around us in the horizontal of the engines, also in the autopilot. Over here the airspeed, all the data that we have. So we will look outside. We need to start the turn of the aircraft to follow the flight plan over here. Also the airport as we depart. So we start the turn like this. Keep flying. You can see so we keep climbing. As you can see the air data over here, make a little bit left turn. We need to follow this waypoint, the Zui. So we have the airspeed 150 knots, the stall speed yellow and red indication here. We need to avoid the wind, it's 22 knots, this vector. Also here the ground speed of the aircraft, so we're leveling off. Also the engines indication, the flight plan here, the thrust levers. So we can see also the autopilot set over here, and the head-up display. So you can see the airspeed 180 and the altitude 13,000. Flight director. So keep climbing, and also need to use a little bit the flight plan here, better view, as you can see. So we're gonna need that to make some turn now. Very beautiful view over here, as you can see. The Boeing 787 over here. We keep climbing. Also all the Switzerland here around us, all the Swiss Alps, and the Germany, my homeland in front of you, and the France. We keep climbing like this, as you can see. We can leave the hands off from the aircraft, no problem, for as much time as we need. Only need to make small inputs from time to time, as you can see. Only the airplane can do that, stay level with the hands off from the yoke if it is trimmed well and has the right thrust and flap settings. So you can see hands off, no autopilot, and we keep flying. Level on small corrections over here, as you can see. Flight path corrections. So we have 18 more minutes for this flight. Keep flying over here, keep climbing, as you can see. So you see the cockpit again after takeoff. Review. Also this side view. To be aligned now with the waypoints over here. So we have the Negri the next waypoint that we need to fly through. The distance the Negri is and its altitude. So we're gonna cross 20,000. Couple of minutes. Keep flying like this, and we have a few more minutes to go back to the airport. As you can see, also the other side of the cockpit, the instruments, the autopilot, as we follow right now. We have no autopilot connected, but we fly manually, so we can set also over here next waypoint. I'm gonna make the motive over here. So here is gonna be the next waypoint we have to follow. We need to start the turn over here, as you can see. So we overflying Germany here, France, as you can see, Switzerland, my homeland Germany, Bayern Munich, and in front of you. So we have the Switzerland, the France, beautiful view, and we need to start the turn now. So we start the turn, going back to the airport, as you can see. And we keep flying manually. Maybe we connect the autopilot in a couple of minutes for display. Also use right rudder pedal like this to make a better steering control. As you can see, flying manually. So we are here overflying the Germany, my homeland, Bayern Munich, the lakes, and the Boeing 787. So you see manual flight like this. .787 over here, as you can see. And going back home over here. We need to align now. We made a very nice alignment over here with the flight plan. Maybe we connect the autopilot now for display. So you will see how we can handle the airplane with the autopilot on. So we have auto throttle, left and right autopilot. We decrease also the rate of climb like this. So cancel the warning and use a little bit less. So you see, now we have the autopilot engaged. It's gonna follow the waypoints one by one. So it's align us in the right direction like this that we have to be. You can see autopilot engaged over here, autopilot on, and flying through this altitude. You can see the autopilot white indications here that it is connected. This is also so here we are overflying this most beautiful view that we can have right now, and we have 10 more minutes to go back to the airport, as you can see. So we overflying the Switzerland, Zurich. I'm gonna be flying over galactic views over here, very beautiful galactic view. We need to schedule the descent now, top of descent, so we overflying the Switzerland, the lakes over here. So this is the frozen vapors, as you can see. overflying the France over here. So we have beautiful galactic view over here, as you can see, and the frozen vapors of the Boeing 787. So here's a beautiful galactic view. Flaps up, as you can see. It's flying manually with the autopilot connected. So we have the beautiful view over here, as you can see. A beautiful star sign. So we are almost 34,000 feet. We need to advance the descent in a while. As you can see, keep following the waypoints. Over here, autopilot on, engage the airspeed and the altitude we maintain. So we need to descend. Also the thrusts, as you can see, we can use the manual thrust control, override the autopilot. So we need to start the descent now. Descend a little bit lower, the altitude in thousands. Also minus 800 the airspeed. So we can set a little bit higher rate of descent. So we're gonna use idle thrust like this as we're descending. We have the autopilot on, as you can see. Beautiful views over here. Chemtrails behind us. The Germany. We are 22,000 feet, as you can see. So flying now manually, as you can see, as we are descending over here. So now we can fly the aircraft manually, and we have 9 more minutes. We can also connect the autopilot later if we need. So we make a flyover. You can see the airport location over here. Keep descending. Keep descending. 17,000 feet over here. You can see the arc of descent where the aircraft is gonna be at this airspeed and altitude as we're descending. We need to increase the rate of descent like this. So we are 13,000 feet like this. $12,000. We can connect again the autopilot if we need. We will follow these directions, the altitude, descent rate. As you can see, it will align us. Now we have the autopilot engaged for alignment with the runway. The airspeed also, we're gonna decrease the airspeed. It's gonna follow the lines here, as you can see. And now the descent rate over here. We need to align now with the runway position. So here is the turn, as you can see, of the aircraft. We enter over here. we need to decrease the airspeed and the altitude over here. Also decrease the airspeed. Use some landing gear maybe. Align with the runway over here. So now we're flying manually again. This indicates the autopilot like this. We fly with manual thrust inputs whenever we need to align with the runway in a couple of minutes as we are approaching over here. So we have 6 more minutes left for approach and landing. We need to follow the flight line over here. As you can see, fly manually. Align with the runway vectors over here, both sides. Also the autopilot we have disconnected right now. So we have the runway position here. Add some thrust over here, as you can see, for approach and landing. Use a little bit left rudder for this. So we can use also the landing gear now. Down. And also some flaps. Decrease the airspeed like this. So here we are into the runway position for approach and landing, as you can see. So if you look outside, you're gonna see we are very close for approach and landing. So we have the view of the aircraft, very beautiful view for touchdown. As you can see, we need only to align, increase the rate of descent. You use a little bit more right rudder now. As you can see, right rudder helps to align here. Also use more flaps, full flaps. A little bit more airspeed also helps to maintain the airspeed here. We have some wind gusts, some side wind. Need to grab the aircraft with this side wind and the wind gusts, as you can see. So we have also the Lszh localizer here. We can use the Lszh localizer for alignment for approach and landing. We are a little bit higher in the Lszh localizer, so we need to increase the rate of descent. As you can see, increase a little bit the rate of descent, a little bit more airspeed now, increase again the rate of descent. We need to red and to white. Also we need to align with the runway and leveling off with the horizontal tail for the flare. So we're gonna be flaring here, flare very smoothly, as you can see. So this is very beautiful, smooth and touchdown, very beautiful, very professional. So we use parking brakes. We made a very smooth landing and very beautiful. Also thrust reverse, full thrust reverse over here. So we're slowing down now, and we maintain a center line, as you can see. Very beautiful center line. Thrust reversers, full thrust reverse, and slowing down a little bit right, left rather, to align with the center line. And we can exit from here on the next taxiway. We have a lot of runway in front of us. So we made a very beautiful landing, as you can see. Thrust reversers, full thrust reverse like this. So we're gonna use the idle thrust. You can see inside the cockpit, very beautiful. There's everything is fine. So we made a very beautiful landing. We have plenty. So that was Thomas Hatsios, the German American pilot flying the Boeing 787-900-95. Thank you very much for watching me. I'll see you next time. Bye bye. I have a few more things to show you here. So you can see here also from the outside view, you can see the runway. We just landed, very beautiful. runway 14, Switzerland Airport, Hamas. We have plenty of runway for slowing down and 2 taxiways to exit over here, the aircraft. So this is the most beautiful and advanced aircraft in the world. The most beautiful and advanced airplane in the world, the Boeing 787, extremely safe also. So thank you for flying the Boeing aircraft. So you can see here the landing gear, the nose wheel. So you can see all flight controls are fine. We can make our movements. We can also exit the taxiway, but I will show you here. You can see the nose wheel is perfectly safe. There is no breakage. Also the back of the wheels over here, there is no breakage. The forward nose wheel is fine. The wheels behind are fine. The aircraft is starting up the way it should be in the runway. No breakages. No broken systems. As you can see, nose wheel is fine. So we use idle thrust reverse over here. You will see idle. The thrust reverse is closing down. So that was Thomas Hatsios. Thank you very much. I'll see you next time. The German American pilot flying the Boeing 787. See you next time. So we have more systems if you want to see from the Boeing 787. Slide the cockpit a few